Good afternoon. So today's session, I would be taking on data inputting and editing in GIS. So in this session, we are going to learn what are the various sources of data and how we can may input this data into GIS, right? So many times what happens is we know what data we want, we don't know what are the sources. Sometimes we know the sources, but we don't know the process, how we can integrate into GIS. So overall, this lecture will cover how you handle data and how you can input that data into GIS. And then we'll see further how we can do editing. What I mean by editing here is once you import data or do some data collection exercise, there may be chances of some errors. So how we can, by editing, I mean to correcting that errors, how we can correct. And also we'll see in the later exercise how we can follow the best practices so that while inputting data in GIS, these errors can be minimized. So just to brief you about what are the changes which happened here. Yeah, I can see some messages. They're saying good morning. Yeah, I know it's a different time scale here. Yeah, so we are here in evening. So what I want to show here is the source of data which we use in GIS, Geographical Information System, has changed very rapidly. And last 30-40 years, you can see even the instrumentation and the data collection process itself has evolved a lot. So if you see here, the image which I am showing here, if you want to earlier days, say 70s or 80s, if you are before 70s, you want to really collect data, only thing remotely you can do is by using telescope, you can see the object. So range of telescope is the limitation, and if there is any physical obstruction, there is no other option to cross that obstruction, then only you will be able to see, right? So so many times surveyor need to stand in places filled with water, like we can see here. And then surveyor used to use this instrument like theodolite, right? Theodolite for angle measurement. Then there is the leveling instrument. And there are multiple instruments the surveyor used to use. And from that, he used to create map on using pencil or pen or paper. Once he's done the field exercise, he go to the back office. In the office, in his drawing table, he will the rough work he will finalize, and finally these kind of maps used to be created. But if you see how we collect data now is very much sophisticated and easier than earlier process. So the work which even if now you want to go to field, highly likely that you will not be doing the plain table surveying, but you will be using any tablet, mobile phone, and recording the data. This is first stage, right? And now, earlier, as I said, after collecting data, you used to go to the back office, and again, using pen and paper, he used to correct the data, and finally, it will go for publishing. But now, you will come and import your data from your tablet or field instrument and import into computer. Then you will do further task. Yes, now it is possible that you can collect data using the aerial platforms, and similarly, earlier, because as all of you can know, before the digital photographs, we have the reels, the negatives. So that technology also, and at the same time, we have the aeroplanes and flying objects. So what people used to do is first they used to non-digital cameras. They mounted on the aerial aircrafts and took the aerial images. Then the non-digital camera all replaced by the digital cameras. Now platform. The platform is the aircraft. Now the platform itself is also replaced by the satellites. So now digital camera is put on the satellites, and from there also we are able to collect the data. So this drastic change, right? So now if we want to see in detail what can be different sources and the input from where these sources, how I can input into GIS. So first one is called manually digitizing from images and various map sources. So we can have map like a paper-based map. We can have maps like we can have images or photographs taken from the old style, which are not in digital format. And even if it's digital format, they are not georeferenced. So basically, the images and the maps, which are non-digital format, we import them and we manually digitize. So when I say manual digitize, so what can be sources of this? So one can be manually drawn maps. It means they are, as I shown in the picture, they are not digital maps. They are drawn using pen and paper and they are printed. So these maps can be one source. Similarly, most of the countries and most of the areas, the legal records, the land records, they are also, they can be a source of GIS data. So from there also we can extract a lot of features. We can extract the ownership information. We can extract what is the size of the land. So these legal records can, and again, these legal records not necessarily be in digital format. Recently, I can see in our country, government have started making digital legal land records, and some of the states have been successful and some are still doing it. And most of the countries, I believe, still legal records are very ancient formats. They are not being digital everywhere. So so when you are working in GIS, you need to deal with both. Those which are digital, already digital, collected using digital instrument and they are in digital format, you can directly use it. But at many times doing the analysis, geospatial analysis, if you want to go back, you want some data related to 1960s or 70s. So of course, that time digital instruments were not there. So again, we have to depend on the these physical maps or physical records only, because digital records or digital map, that technology was not there. If you go to 90s, 80s, so when we go back in time, so we cannot rely on the modern instrument, because that during that time, whatever instrument they used to use, from there only they collected data. So these legal records also come into picture, and they can be one good source. Another way is list of coordinates in the tabular format. So we have a different objects name, and correspondingly their coordinates are been written. They can be imported into GIS. And last one, what I'm talking about is aerial photographs. So during this lecture, whenever I say image, so we mean image means digital, and photograph means non-digital. So photographs are based on negatives, they are developed into positives and they are printed. So they are called as a photograph. So there are many aerial photographs which are non-digital but printed format. From that also we can extract information and we can convert them into digital, and that process is called digitization. Right? So this is one category. Another category is field coordinate measurements. So sometimes we will have the coordinate measurement using the surveying instruments. So coordinate surveying can be used using the surveying instrument, where for a few distinct features or objects, we calculate the coordinate, and that coordinate will be imported into GIS. Similarly, you can use GNSS or GPS, Global Positioning System or Global Navigation and Satellite System, where using that instrument also you can calculate your coordinates. So when you use it field, in the field visit, you can calculate the coordinate of each location, and that location can be work as an input to GIS. Finally, image data. So image are those which are already in digital format. So half of the job is done. So we don't need to convert to digital. But again, from there also we'll see in the exercise what are the work you need to do. If your image data is georeferenced, so what will happen is, because it's an image, so image itself, if image has some, say, we are talking about a satellite image, it has some ponds, it has some fields, it has some trees, but image itself will not tell you that, because it requires some interpretation, because image will only show the colors, right? If you have a color, say, color image. So we have a red, green, and blue. So combination of that will make multiple colors, and image will look like each object with different color and different shapes. Based on that, either we can manually classify, okay, the segment here is this object, segment there in that object, or we can use automated algorithms which classify. So from and that after classification, that will be actual information which will be used in GIS. So most of the time, GIS, unless you convert your raster into vector, you don't find any meaningful value if you see in perspective of the GIS. So for that, we can use manual or automated classification technique. And sometimes we directly create image, right? So that is called direct raster data entry. So most of the time you use sensors to create vector data if in digital format, but sometimes you can directly create raster also. So raster data can also be directly in digital format and it can be used in GIS. So as I was talking about manually drawn maps, so what is the best example is the topo sheets. So what will happen is when you have a topo sheet, these are manually drawn. Now you, based on based on coordinate survey, they have been drawn using either plane table surveying technique or any other techniques. They have finally manually a map is drawn and they are plotted and printed very carefully in a paper or say sometime paper made with cloths also. You can find out many topo sheets are printed on cloths. So these topo sheets can most of the time, if you want to have a data of ancient time, these topo sheets are very much useful, and these topo sheets can be digitized in GIS. So what basically digitization means, from here I want to extract objects, I want to extract mountains, I want to extract water bodies, I want to extract elevation of different features. So these things are roads and other things. By use the legend, I can extract, and GIS will help you in extracting these features. So similarly, when I was discussing about field measurement, so you can see here nowadays the modern instrument, it is also called total station. So total station is nothing but a combination of a distance measuring device and the angle measurement device. So angle measurement is called theodolite, and distance measurement, if you see this kind of instrument, we call it EDM, electronic distance measurement device. So electronic distance measurement device along with the theodolite will help you to calculate, because you know the distance, and because based on the time of flight of the light, so light will go, you focus on an object, it will interact, it will reflect back. The time it takes, more farther is the object. So based on that, automatically this instrument, it record the time, and once the time difference into speed of light, you will get the distance, and that distance along with the angle. So we have a distance and angle. It means we can calculate this horizontal distance and vertical component. And if you know your coordinate where you are standing or corresponding to your current location, you can measure its coordinates. And once you add that, you will get the coordinate of the remote object. So this is generally total base coordinate measurement device. Similarly, GPS, you can see here, we have established an antenna here, and this is the receiver, right? So this is the antenna's receiver, and so whatever coordinate we are measuring, which will be recorded by an instrument here. So this instrument is connected to this antenna. So coordinate of this position will be calculated. Now, if I enter the height of this panel, that can easily be measured, it's marked height in the instrument. So automatically the coordinate of this position where this antenna is established, that can also be calculated. So what will happen is these all calculation will be done by instrument. Only thing you have to tell what is the height of the antenna receiver, and then based on the whatever coordinate calculation is done using GPS, from there corresponding height will be subtracted and the coordinate of this ground point will be calculated. So the most nowadays, only thing you need to supply the parameter, and instrument will keep recording the location, and this location also act as a good source for GIS data. And if you see now we have a lot of satellite images available, aerial imagery available. These imageries can be converted into various kind of maps. You can convert into soil map, you can convert into forest area map, you can even if you have high resolution image, you can see what are the different crop types available in different places. So all these can be calculated. So or that can be derived. So and then both are digital format. So there will not be much hurdle, but we'll look into detail how we going to achieve that. Right. So now, in order to do this digitization, if you don't have the digital maps, in the case of say topo sheets, so you have option. Only option is you need to use scanner and digitizer. So again, scanner. If you have a long or bigger maps. It is like if you see these are called drum type scanners, right? So what will happen is if you are using plotter, you may have seen it is reciprocal printer. If you cannot print flat using the flat printer, you have to use drum for printing very long and wide images. Then similar to that, if you want to scan, then also you require structure similar to a plotter. And this is called drum time scanner. So you put your map and it will rotate and scan entire map, and that image then scanned map will become an image, and that image will be accessed in using any digital instrument like computer. Another one, this is called flatbed scanners. So here it is very simple. You put an image there, close the lid, and you can scan. So it comes in various size A4, A3, A1. But if you want to go bigger, then or lengthier, then this drum type scanner is the only option. And before of this scanner, which can actually directly convert this into image, we used to have a digitizer. Earlier digitizer means you have a grid and you put the image, you put your manually drawn maps below, and on top of that you move your cursor and record each location, and that will be recorded in a digital instrument. And that used to be called heads down digitizer, right? Because in table you need to look bottom and digitize. Now after that, before the computer become mainstream, some people started making heads up digitizer. Nowadays they are replaced with your computer and monitor. So heads up means your monitor is front, and you can, after scanning, you can directly use that to digitize. So scanning will do the half part, which convert to, or this digitizer will do convert to a image. Then digitizing means actually creating vector data from the topo sheets, extracting rivers, the line feature, extracting various buildings, maybe point feature, extracting various polygons like forest area, agriculture field. So all these things, we earlier digitizer used to do this approach, old approach. A modern day approach is using computer, you can digitize. So it may happen that most of the time when you are starting GIS work, the legacy data, you need to use the scanner. So that's why these two scanners are very important. And how you measure the quality of the scanner is called the dot per inch. And this is very important because not only the instrument can have very good DPI, means 1,000 DPI, 10,000 DPI instrument. But if you use same DPI or resolution of the scanner, then what will happen is after scanning, the output will be very bulkier, right? So for that, it is very much required that we choose the optimum dot per inch while accessing the scanner. So modern day digital scanner, they give option while scanning, you can configure in what resolution you want to scan. Similar to printer, like you can say what resolution you want to print. Similarly here also. So dot per inch means in 1 inch, how many dots? So you can equate this with the pixels, right? So this is simple one, just to think. And you can try to solve this. If a scanner has 10,000 by 10,000 pixels, and this size is 10 centimeter by 10 centimeter, so how many dots will be there in per inch? Right? So 10 centimeter, 1,000 pixels. So 1 centimeter, 100 pixels. And so we can say 100 dots per centimeter. But if you want to convert that into per inch, so 1 inch we have 2.54 centimeter. So 2.54 into 100 becomes 254 is the DPI. It's clear? So means in single inch, you will have a 254 dots. So now again, coming back to this, how we decide how much DPI I should use. So there is a concept in mapping is called minimum mapping unit. So what you can calculate is based on the scale, you can calculate your minimum mapping unit. So generally minimum mapping unit terms came from when the surveyor used to use the pen to mark a point. So the size of the tip of the pen used by the surveyor it become the least count of your surveying. So you can, because the pixel smaller than or any mark smaller than that dot is not possible. So say generally we say 0.25 millimeter, right? 0.25 millimeter. Say if it's the thickness of or the size of the tip of the pen, then 0.25 millimeter multiplied with the scale of the map, you will get what is the minimum mapping unit, right? So if in the paper, if you have a A4 size paper and the 0.25 millimeter is the minimum measure size, so 0.25. So for 0.25, I need to calculate how much is the DPI required, so that I don't want to miss any 0.25 millimeter in the paper, right? So 0.25 millimeter means, so in 1 centimeter, 4. So 1 centimeter, 4 dots, and 2.54 centimeter, it will become a 10, right? So based on that, you can calculate the DPI required for scanning, where you on your paper, you don't want to miss any 0.25 millimeter. Same way, if your actual image which is drawn, suppose he has drawn in a A1 size paper and that is reduced to a A4 size paper, then what will happen? Correspondingly, your dot size will also reduce. So 0.25 millimeter will reduce the four times. So that will become the minimum measurement you want, and you should choose DPI such that your DPI should not be less than the minimum measurement unit. Okay. Yes, I can see some people have given answer for this quiz and say B. So 1 centimeter, we have 100 pixels. So 2.54 centimeter, yeah, 25.4. Yeah, 100, and 2.54 into 100 will become 254, I think. Yes. So that you can calculate, but idea is this DPI you have to choose based on the minimum measurement unit. So the rough idea which I am giving you, if you are normally minimum mapping unit is 0.25 millimeter, and this 0.25 millimeter for the actual drawn one. And once this drawn one will become, if you are reducing that, or it is reduced and printed, then of course that size will also reduce. So based on that, you can choose the DPI. So let's go in detail how we do the manual digitization. So first you take an image or map, and then you scan it. So after scanning, it becomes an image. Now this image, so if map is there, paper-based map, you have to scan. If image is there, you directly take it. You don't need to do scanning. Next, now map after scanning become image. If image is there, it's already image. So go to next step 2. Now image, if image is there, so either scanned one is not georeferenced. And if you directly got the image, if it is not referenced, you have to georeference it, or you have to reference it. That referencing means each corner, each place in the image should tell me about the ground coordinate. And for that, we require a ground coordinate, or we require measurement of control points. So control points are those points which are visible in the image. And so I know all the points for which I know the location in the image, and also know its corresponding ground coordinate. So you first in the image you identify a prominent points which are easy to trace in the ground, and then for the same point you go to the ground and calculate its coordinate. That is one way. Another way which generally people do is, suppose you see something in image, you go to any high resolution georeferenced image, say Google Maps, Bing Maps, or OpenStreetMaps, and try to find out same object there and note the coordinates. So there are two ways. Either you go to ground and calculate the ground coordinates, or you use third-party resources which are already available and get its coordinates. Right? Then in the GIS software, you need to digitize that control points. So what we'll do, in the image you will select one point, and corresponding point you will create a point, and correspondingly you will enter the ground coordinate which you have measured from the either directly from the ground or any high resolution source, and both need to be stored, and that is called digitizing control points. Once you know the control points, now when you give command for transform or register to computer, basically what it does is it calculate the parameters to fit your ground control point to the image point. So you know the image point xy, small xy, and ground coordinate capital XY. So we need to establish relation between small xy and capital XY, right? So either you can do polynomial fitting or you can do matrix transformation. So you need to, based on 3, 4, 5, 6 these ground control points, it will calculate a transformation matrix, and then once you get the transformation matrix, that is applied to entire image. Understand? So for based on the first to establish mathematical relation between the map coordinate, which is not a reference to image coordinates, and to the actual ground coordinates. Once you get that relation, you need to transform it, and that is also done by the software. Once you apply that, entire image based on the control point, entire image will be registered, and then you have to choose a coordinate system, and you will save it. So once you save it, now my map, the image which has georeferenced is now georeferenced. So if you move your cursor any place, in the image, you will get a ground coordinate. And this ground coordinate, now by using that, you can digitize either using stream mode or point mode. Now is the task. What you want to digitize? As we learned in GIS, GIS has 3 kinds of data: vector data, point, line, and feature. So now by seeing the image, because image has coordinates, so if you see any object there, you create a point, automatically in that coordinate one point will be created. If you want to create a line, so then you have to collect a line. So how you do digitization? Point is simple. You click, you create a tick. But for line and polygon, there is 2 modes in normal GIS software. One is called stream mode, another is called point mode. Right? So what will happen is in stream mode means you keep moving your hand and it will keep going like this. So this is stream mode. So if you are an artist or you have very good control hand-eye coordination, so you seeing a river here, so you can keep connecting, moving your hand, and automatically this will be digitized. This is called stream mode. Another one is called point mode. So what I will do is I will click on one point and clicking on this point, and GIS software will join this point to create a line. Right? So basically I am making points, but by process the line is being created. So this is one is called stream mode, and another is called the point mode. Yeah, mostly I personally prefer using point mode because there is less chance of error, and in relaxed way you can do the digitization. And another mode is called stream mode. There also you can digitize. So seeing the background image, you keep moving, creating line or vector feature, and that is called this is second one is called point, and this is called the line. or stream mode. Now let's see some challenges of scanning. What will happen, as I told you, if you use very high resolution scanner and you scan it, so what will happen is if you zoom in, because the image you can zoom as much you want in the GIS software, and so you zoom further and further, you may see that even the linear feature, you can see the pixel boundaries, right? So what basically you need to do is, if you want to digitize, you keep clicking from the center and line would be created. So you don't, it doesn't mean that always you need to create polygon or something. Even a linear feature, if you zoom in, you can get the pixel boundaries and you just need to draw the center line. That is one option. Second option, okay, that I will cover later. But second, what I want to cover now is, this is one way of scanning. Another way of scanning is, if we give you an example, here, I have different features. So even suppose each color shows different features and I have scanned it. So I want to make all green color into one polygon, this red color one, yellow color one, and this purple color one. So that is also possible. And this either you can do manually by digitizing this, or you can use computer algorithm which raster to vector, which based on the color automatically convert that into different polygons. Right. So as I told you, if you want to digitize manually, you have to do this, and this can be done manually and both automatic and manual. So manual digitization we do, and in automatic digitization we basically use computer algorithm. So for this kind of scenario, automatic digitization is very much clear. But this kind of scenario, we don't know. Suppose this is a road network or this is a river bed. So we don't know which way river is going. Means this is the main river or this is the main river. So what will happen? Even the automatic algorithm will stop there. So it's called semi-automatic. Each stop you need to again tell that, okay, from there go to left or right. Then it will keep digitizing. And even though automatic digitization is useful, but it is only popular in from raster to polygon conversion. You know, apart from that, whenever you do raster classification or something, you can convert it into polygon. That up to that is fine. Otherwise, if you want to draw a linear feature and other thing, automatic digitization again require after digitization lot of correction and manual intervention. I told you if roads are dividing intersection, these things are very complex and it require, even though after doing automatic digitization, lot of editing is required. That's why among the GIS practitioner, manual digitization is very famous. So we'll go in detail about how we do the manual digitization. So in the digitization, it is nothing but from the geometry, right? In the geometry, what we'll do is we create a point, right? So from the points, by joining the points, you create line, and by joining the lines, the polygon can be created. So each point or which we create while digitization are called vertices, right? So these are vertices, and these are vertices, and the start and end will be called as a node. So nodes define the start or end of the any line or line segment, while vertex define the shape. So here this is the node and these are the vertices. So based on the vertices, shape of this linear feature is varying. So if you move this vertex here, it will slightly become less curvy, right? And another vertex here tells us that this linear feature has stopped here. Similarly, this one node. Now you can see the node, one node here and one node here. We can have two different linear feature. One directly coming due to these vertices here. So there are two linear segments and both have the common start and end node. Right? So node and vertex is clear, I think so. So what will happen is when you do manual digitization, you need to always tell the computer what is the start. Means you need to, while you click, you have to have separate method for defining node and vertices. So first click will become a node. Then after every clicking will become a vertex. So some computer, when you do right click, it become an end node, or double click, it become an end node. Right? That is a manual digitization process. So when we do the manual digitization process, what happens is there are chances of many errors. So some of the common error I have shown you in the slide. So one is called undershoot, one is called the overshoot. And later in the exercise, we also see how we can avoid these common errors. So what do you mean by undershoot? Undershoot means the vertex which is here. So while digitizing, I actually intended to join here to this line, but it didn't join. And another case, because I know this undershoot problem, I zoomed a lot at I actually over passed the intended point. So it is called overshoot. So undershoot and overshoot. Because again, I told you, after scanning, when we go to the GIS software, you have an image. So there is no limit in how much zoom you can do, right? So these two errors can come. Then what will happen is when you do any GIS analysis, so these two linear features are not connected here, and here it is connected but overshooting. So both are wrong. So this is a common error. Similarly, while digitizing, another kind of error can come is when you digitize a polygon, you may have a dangling node. So basically, this node is again error, digitization error. These are the spatial one. Some non-spatial which can happen is you forgot to enter the name of the polygon. You forgot the name of the or label of the point. So these are non-spatial data entry error which can happen. Then while intersection, if you really want to show computer that this is intersection, you should have a node here. So because we are working on a two-way, because we are using a computer and we are using a two-dimensional maps. So actually this scenario can come. Why? If suppose there is a flyover, so then the road below and road top will be crossing each other, but they are not intersecting because third dimension is not stored. So to avoid that, so if you don't do an intersection point here, so it will be like two roads, though they have one common point, one place there is common coordinate, but they will be not intersecting. If they are really intersecting, then you have to create a node here. So these are some common errors which generally happen in while digitization in GIS. Right. So let's see a case here. I have taken a satellite image. I have tried to digitize, and then I find out that this feature, right? So this feature here, right? This feature I am not able to connect. Either it should be a road or it should be boundary of the forest, but it is in between. So there is some error here. And this polygon feature, I'm not able, why it is here? I'm not able to guess it. So probably it's an error. So now after digitization, either by you or someone else, when you get this data, you need to correct it. So simple way is, suppose you think it is an error, you select this polygon and delete it. That's the most easiest one, right? Then second option is you select and you make each vertex editable. Then you move each vertex down, right? So this is called modifying the edge. So once you modify the edge, the shape will change, right? These are the two things, but still it doesn't solve the problem of overshooting and undershooting. And for that, we are going to discuss very important concept. Those who are first time using the GIS software, they may be able to appreciate it. There is an option in all GIS software. Either you are using QGIS or ArcGIS or any GIS software. There are two options for editing. One is called line snapping, another called point snapping. What we mean by snapping is it will connect to the closest point. So in line snapping, what will happen is whenever you are digitizing, So whenever you are digitizing, say I have a line here and I am digitizing point here. So whenever you come close to this line, automatically it will be joined to this line within the range. Whenever you within threshold range, so it will be snapped to the line. So there is no way that you can overshoot or undershoot. If you are within the range and that threshold, that range you can define. And point snapping, again, point snapping means here, if suppose I am again digitizing here, coming here, and as soon as I come here, automatically it's attached to it. So in the point snapping, the new point is not created. While in the vertex snapping, though, there may not be vertex here in the line, but new vertex will be created and it will be joined. So in the line snapping, vertex will be created, and the point snapping, existing point, it will join. This figure, you can clearly see what is the advantage of using snapping. If you don't use snap and you are digitizing, this will be the data. Now, if I am using snapping, I have enabled snapping in the software. So while digitizing, what will happen is, because this is within threshold, it is automatically joined. Again, here also point snapping, they are within distance, so automatically joined. And here also overshoot problem is solved. And this, because this may be the genuine case where it is not joining with the line, because based on our assumption that within this threshold only we can have a snapping. So if you want this to also be to join, or if you think this is also undershoot, so you can increase the threshold. So automatically, while digitization easily, even if you click here, it will join to the road here. So this is called snapping option. So whenever you are doing a digitization task using any software, don't forget to enable snapping based on your requirement. You can have somehow node snapping, somehow vertex snapping, somehow line snapping. So if line snapping is there, then what will happen is in the new point will be created. If I switch off the line snapping, then this point will not join here, because it will only look to the existing nodes, and it will join to the node if it comes under threshold. Similarly, some software provide vertex snapping, so there should be some vertex here in the figure, and to that vertex only it will join. But if line snapping is on, so nearest point on the line, it will join. Yes. Again, manual digitization, those who are practices, you know that this is also a cumbersome project requirement. So suppose some of the people who take their job very casually. So what will happen is, in order to digitize this curvy feature, they will clicking some point here, some point there and there. So if you have too few vertices, what will happen is shape will be distorted. But it will take less memory, so file size, everything will be less. But at the same time, we can have a separate time of operators who is very interested in digitization, and he is digitizing and making points very nearby. So what will happen is, though the shape will be good, but the overall size of this linear feature will increase. So storage and other problem, and of course it will take more time. So they require the vertex density need to be set in such a way that automatically your data should not have much vertices. At the same time, it's not too few vertices. So this vertex density also modern GIS software you can define. So what will happen if you have defined that minimum distance should be, say, 5 pixels. So two vertices cannot be created less than 5 pixels. Even if you want to create, it will not get highlighted. Once he go after the 5 pixels, then only he will be allowed to create a point. So in this way, you can define what should be the maximum and minimum vertex density, and that will reduce this problem, too few vertices and too many vertices problem. Right? Now, if you see automated digitization, so this is used for line or point or polygon extraction from the hard copy maps, right? So we have to give some suitable threshold, and of course this hard copy map should be clean and they should not have any scare or marks on the map. So if it is very old, say a treasure map, so it may have a lot of unnecessary marks and it will confuse the algorithm, so automated scanner will not work, right? And still, if you are able to provide some threshold to the software, it is able to do it, then still sufficient work will be required. So some of the work which we'll discuss is called thinning. So what will happen is, if you do automated scanning, suppose my instrument is scanning a linear feature. So first this will come, and again, you know, a linear feature will not have a width. So then you have to do thinning. So thinning is simple. All the center pixel, only one pixel with after the digitization need to be selected, right? Once you do thinning, that you convert to raster. So now each pixel is joined here. Then this raster, because scanning is raster, now this raster to vector conversion we have to do. And to do that, for each pixel, the center of the point, center of the raster pixel will take as a point, and these points will be joined to make a line. So these 1, 2, 3, 4, 5 steps need to be done, and these steps can be automated, and sometimes user intervention may be required. And then, so it means from this image, after smooth line, we got the linear feature automatically. So sometimes based on color, you can extract linear features. And when you have a direct vector input, say vector point, shape file, or any other file, you can directly import into GIS. GPS files, also GPX file, Excel files, they can be easily imported into GIS. Geocoded satellite images can be directly opened. Now, if you are using any image classification software, so output of the image classification mostly is a raster, but that raster can be added to the GIS. Then vectorization of raster, which I earlier also we discussed, you can convert a raster into vector based on this color value, or based on its DN value, or based on the some raster attributes. You can give some threshold or parameters. Based on that, it can be vectorized, and each vector will have a common raster attribute value. So in short, today's lecture, if I want to summarize, if you want to scan or digitize anything, first thing is you require an image. If image is not there, use a scanner to convert that into image. Then if your image is there now, image can be of two possibility. One is georeferenced image, one is non-georeferenced image. So modern days, our satellite image will come as a georeference, so you don't need to do georeferencing. If it is not georeferenced image, then to reference that, you need to choose some points in the image, and for the same point, you need to have a ground control. The ground control coordinates or ground coordinates, you can either get from the ground, or you can go to the any high resolution images sources like Maps, Google Maps, or Bing Maps, or Bhuvan Maps for Indian data, and from that you can get the control location. And this control location you need to digitize, and then you need to use the register or transform option in the software, which basically calculate the relation between the image coordinate and ground coordinate, and then it will apply it to entire image, and that image again, entire image you can save. Now in the digitize, if you have already georeferenced image, on that image, you can digitize using either stream or point mode. And also see that while the digitization, you can use snapping option to avoid undershoot and overshoot option. And editing, we also see editing, we can don't need to always delete the entire feature, but you can drag your individual vertices to change the shape. Okay, that's it for the today's class. If you have a question, I will be happy to answer that.